They're playing basketball
all around the world. To the beach, y'all. Let's go. All around the world. Y'all know this is so that. To the beach, y'all. Yeah.
Basketball is my favorite sport. I like the way they dribble up and down the court. I keep it so fresh on the microphone. I like no interruption when the game is on. I like slam dunk to take me to the hoop. My favorite play is the alley-oop. I like the pick and roll. I like the give and go. And it's basketball. Bow wow, let's go.
All around the world. Yeah, to the beach, y'all.
In my hands, ain't no telling what I'm gonna do with it. When I got possession, I'ma act a fool with it. I might cross you up and fake one way, turn around and hit you with the MJ fadeaway. I'm throwing down passes like J Kidd, taking catch to the rack, and I'm dunking on them like C-Mac. When I'm at the plane, I play with that Alonzo style. I'm like Darius, cause I can
Don't too many players get offers like me. Back and forth are likely.
Hey guys, it's Ms. Gardner. I'm going to start us off with our elimination method for solving systems of equations. So the one I'm doing is kind of like our easy variety, so we can eliminate a variable right off the bat without changing anything. So when I look at our equation, I notice that my x variable, its coefficients are the exact same. One is positive and one is negative. So coefficient is just the number in front of your variable. So this positive 3 and negative 3 are going to end up eliminating. That's what I look for. So for the elimination method, I'm going to add my two equations together. So when I add positive and negative 3, they're going to add up to 0. So in my mind, I think of these as being eliminated. So I put an E above them just so in my mind I'm reminded they've been eliminated. Everything else you're just going to add straight up and down. So 2y plus negative 3y gives you a negative 1y. And then our numbers, negative 20 plus 15 is a negative 5. Once I'm at this step, I know I'm going to have to divide by the number in front of the variable. So divide both sides by negative 1. That is 1, so I can just write it as y equals negative 5 divided by negative 1, which is positive 5. So at this point, I know my solution is going to be something, comma 5. My solution is always a coordinate point, so now I just have to find x. Now that I have this first variable, I go back to my substitution method, back to one of our first equations. So it doesn't matter which one you use. I usually like using the one with less negative signs because I think it's easier. So I'm going to use this top equation, and I'm going to write the equation the exact same, except instead of 5, or instead of y, I'm going to plug in or substitute a 5. So the top equation becomes 3x plus 2 times 5 equals negative 20. Our first step to simplify is just to do our multiplication. So 3x plus 10 equals negative 20. At this point, if I'm trying to isolate x, get it by itself, we know that positive 10 has to be moved to the opposite side. So we use our inverse operation. So we will subtract 10 from both sides. It will cancel out on the left, leaving us with a 3x equals negative 20 minus 10, which is negative 30. And then just like our last step over here, in order to get the variable by itself, we're going to want to divide by the number in front of the variable. So divide by 3, giving us x equals negative 10. So now that I know my x value, I'm going to go ahead and put it into my coordinate point here. So my final answer will be negative 10, comma 5. And now you know more.
Awesome here. What's up, Mustang? So what we're going to do is the next level of elimination problems. So as Ms. Gardner did, she did the easier one where you don't have to change it. You can just eliminate and find your point of intersection. So on this one, first of all, what we need to do is make sure our x's are lined up, our y's are lined up, and the numbers are lined up. So that way you are combining the correct variable. So I look at the x and I see that I have -3 and 5, so those are different. So I want to maybe, it's going to be a little bit harder to try to figure out a number that I'm going to have to multiply with that. So instead I'm going to look at the y value. I notice that I have 2y and 2y, so they're the same number, which is good, but we need a different sign to eliminate. So what you need to do is that you need to multiply one of these equations by a -1. Or if you don't understand the multiplying by a -1, just know that if it is a +2 and a +2, or the same symbol and the same number, just change the signs of one of your equations. So there's two different ways to think about it. So what I'm going to do is I'm going to take the second equation here, and I'm going to multiply everything by -1. So what that does is change all the signs in that equation. So instead of 5x, it becomes -5x minus 2y equals +17. So what we did is we changed this into this equation. So what I like to do is kind of just cross this one out. So now you know what you're working with. You have this equation and this equation that you're going to combine. So now I just combine vertically. So as Ms. Gardner said, you can add down, or you can just perform what's happening with each coefficient. So for instance, -3 minus 5, you could do that, or you could say -3 plus -5. In this case, that is -8x. We eliminated the y's because we have 2y minus 2y, or 2y plus -2y. Either way you want to look at it. Then you have 23 and 17, which that adds up to be 40. So then the last step here would be to divide by -8. I get x equals -5. Okay, so x equals -5. So now that we have x, we know that we have -5, and then we need to find our y value. So you go back up and you pick one of your equations. I'm just going to pick the -3x plus 2y equals 23. I'm picking this one. X is -5, so I plug it in where x is. -3 times -5 plus 2y equals 23. We get -3 times -5 is +15, plus 2y equals 23. Okay. And the next step is to subtract 15 from both sides. So this is gone. I get 2y equals 23 minus 15. If you can't do it, make sure that you get your calculator and it's 23 minus 15, not 23 minus -15, because sometimes you make that mistake. So if I take 20 minus 15, it's 8. And then you divide by 2, which gives you y equals 4. So I have my y is 4, my x is -5. So I want to make sure that I have that in. This is your final point of where those two lines intersect. Now you know more.
Hey, Mr. Hart here, and now we are going to continue looking at the elimination method, but we're going to look at a problem that involves multiplication. So before, what we always like to say, if the problem sets up with x and y on one side and then your regular number, your integer on the other side, elimination's typically going to be the easiest. If either your x's or your y's are opposites, it means they will cancel each other out. You can just roll right into it. Or like the video that Mr. Gossam just did, if all you have to do is change the sign, you can go into it as well. And it's a little bit simpler. But this problem, we still want to use elimination, except my x's and my y's, neither one of them are opposites, meaning neither one of them will cancel out. So what I need to do, I need to figure out what can I do to either my x variable or my y variable to make it to where they are opposites or they'll come out to 0 if you were to combine them. So the way we want to check this, I want to look at my x's first. I want to think, can 2 fit into 6 evenly? Or is there a number that I can multiply 2 by to get 6? And yes, there is, 3. So that is an option. Then I want to look at my y's, and I want to check the same thing. Can I multiply 3 by something to get 8? And no, there is not. So for this problem, I'm going to have to eliminate my x's. But again, we have to use multiplication. So if I want to cancel out my x's, if this is a 6x, we typically want to take our smaller number that's attached to the variable and multiply it to get rid, or to match the bigger one. So if this is positive 6x, I need this to be a negative 6x. So then I have to ask myself, how do I turn 2 into negative 6? Well, I know that I have to multiply it by negative 3. Now, the thing is, if you multiply something by one of the equations, or one part of the equation, you have to multiply the entire equation by that number. So I have to multiply this entire equation by negative 3. And we want to think of this like the distributive property. So I've got negative 3 times 2x, which gives me negative 6x. That's what I wanted. That's why we're doing this. Then I've got negative 3 times positive 3y, which is going to give me a negative 9y, equals negative 3 times negative 1, which is positive 3. And now from here, it just sets up like a normal elimination method. So my x's cross out. I look at my y's. I've got positive 8 and negative 9. What I like to think about, instead of adding or subtracting, is just combining. So I have 8 positives and 9 negatives. When we put all those together, we have more negatives than positives, and just one more. So we have a negative y equals negative 8 and a positive 3, which gives me a negative 5. Now, our goal is to get y by itself, and even though there's not a number by it, it's still not technically isolated. So I have to get rid of that negative, and what we can do, we can just kind of multiply everything by a negative 1, or just a negative, just like what we did earlier. So again, it's kind of like the distributive property. So a negative negative y is a positive y, and a negative negative 5 is a positive y. So once I've found my y value, I can use that to find my x value. So now we kind of go back to the substitution method like we've been talking about. So I want to take y and I want to substitute it into one of these equations for y to figure out what x is. Now technically, it doesn't matter which one. I can do my first original equation, my second original equation, or I can do this third one that I've gotten when I multiplied the first one by negative 3. What I like to do, I like to plug it into the equation that looks the most simple or looks the easiest. And to me, it's the top equation, the 2x plus 3y equals negative 1, just because the numbers are smaller. So I'm going to take 2x plus 3y equals negative 1. And since 5 equals y, I've got to put the 5 right where the y is. So we keep everything else the same. Whenever we substitute a number in for a variable, we want to use parentheses. And now we just use our algebra skills to solve from here. So when I see parentheses, I know I want to get rid of those. So 3 times 5 gives me 15. So we have 2x plus 15 equals negative 1. Now we're trying to isolate the variable, so I've got to get x by itself. The easiest thing to get rid of is the plus 15. So we want to do the opposite, which is subtracting 15, or a negative 15. So those cross out. I have 2x equals. Now over here, I have a negative 1 and a negative 15. Again, sometimes it gets confusing if you think negative 1 minus 15. So I just like to think of them both as negative numbers, and we're just putting them together in one pile. So if you have 1 negative and 15 negatives, and you put them all together, I have 16 negatives now. And now to get x by itself, we just have to divide by 2. I have an answer of x equals negative 8. We want to write our final answer and make sure it is clear, x value, comma, y value, and now you know more.